Most people think sarcopenia, the gradual loss of muscle mass, is just part of aging. But what if you could fight it deliciously? In this video, we're diving into 5 specific cheeses that do more than satisfy your cravings. They actively help rebuild lean muscle, support anabolic hormone production, and fortify your body against the breakdown that comes with age. If you want to age strong, stay functional, and maintain a lean, metabolically active body, don't skip this. Let's break it down. Sarcopenia is age muscle loss, a progressive, insidious condition that doesn't just impact the elderly, but often begins far earlier than most people realize. In fact, this silent form of physical decline can start creeping in as early as your 30s. While you may still feel youthful and strong during this period, the physiology underneath begins to change. Each decade after the age of 30, the average adult can lose anywhere from 3% to 8% of their muscle mass if no corrective action is taken. By the time you reach your 70s or 80s, that cumulative decline becomes not just visible, but debilitating, often leading to frailty, metabolic disorders, and impaired mobility. What makes sarcopenia particularly dangerous is that it doesn't announce itself with sharp pain or dramatic symptoms. Instead, it shows up subtly. You notice your strength is waning, your endurance is lower, and your recovery from physical activity takes longer. Tasks that were once effortless, climbing stairs, lifting groceries, rising from a chair, begin to feel burdensome. But this isn't just about strength or vanity. Muscle is metabolic currency. Your skeletal muscle isn't just a system for movement, it's an endocrine organ that plays a powerful role in blood sugar regulation, hormonal balance, mitochondrial health, and fat oxidation. Muscle tissue serves as a reservoir for glucose, which helps control insulin sensitivity. So when muscle mass declines, insulin resistance can rise, increasing your risk for type 2 diabetes and other metabolic syndromes. Compounding the issue, sarcopenia is often accelerated by modern sedentary lifestyles, chronic stress, poor dietary choices, and nutrient deficiencies. The typical Western diet, high in refined carbohydrates, low-quality fats, and synthetic proteins, fails to provide the essential amino acids, minerals, and cofactors needed for muscle synthesis and repair. Meanwhile, the overconsumption of inflammatory foods leads to elevated cortisol, which further degrades lean tissue and inhibits muscle-building hormones like growth hormone and testosterone. Additionally, insufficient protein intake, especially bioavailable protein, is a huge factor. Many people believe they're consuming enough protein, but the source, timing, and digestibility of that protein matter immensely. Not all proteins are created equal, and muscle protein synthesis depends heavily on high leucine, complete protein sources combined with a resistant stimulus. Simply eating more chicken breasts won't solve sarcopenia if the digestion is impaired, or if the muscle building signal isn't triggered through strategic physical movement. And here's where aging itself becomes a double-edged sword. As we age, the efficiency of our digestive system declines. Stomach acid levels drop, pancreatic enzymes decrease, and the microbiome changes, all of which impair our ability to break down and absorb critical nutrients. So even if your diet remains unchanged, your body's ability to utilize those nutrients diminishes. Sarcopenia isn't just a matter of getting old, it's a matter of biological dysfunction. This is why even active individuals who don't adjust their diet and supplementation to account for these changes can experience accelerated muscle loss. Muscle is not preserved by accident. It must be stimulated, fed, and protected with intention. Further complicating matters is the misunderstanding around weight. Many people lose muscle mass while maintaining or even gaining weight due to increased fat storage. This gives a false sense of security. You may appear normal on the outside, but inside, you could be suffering from sarcopenic obesity, a condition where fat mass overtakes muscle mass, putting the individual at even greater risk for insulin resistance, cardiovascular disease, and hormonal imbalances. As testosterone, DHEA, and growth hormone decline with age, the muscle-to-fat ratio deteriorates rapidly without nutritional intervention. Add to that a lack of sunlight exposure leading to vitamin D deficiency, poor sleep hygiene affecting growth hormone production, and low levels of physical resistance, and you have a perfect storm for muscular atrophy. However, sarcopenia is not inevitable. The human body retains a powerful ability to regenerate even into old age if given the right signals and substrates. Nutritional strategies such as increasing intake of bioavailable protein, leucine-rich foods, and nutrient-dense fats, especially from sources like grass-fed cheese, eggs, and bone broth, can provide the building blocks necessary for repair. Resistance training, particularly eccentric loading and slow, controlled movements, activates satellite cells and promotes hypertrophy even in older adults. Inflammatory markers can be reduced through fermented foods and omega-3 fats, helping to create a hormonal environment conducive to muscle growth. Additionally, targeting mitochondrial health through compounds like CoQ10, alpha-lipoic acid, and carnitine can enhance energy production at the cellular level, further supporting muscle function. Understanding sarcopenia means recognizing that muscle isn't just about movement, it's about metabolism, immunity, strength, resilience, and independence. The loss of muscle is not just physical, it is emotional and psychological as well. It erodes confidence, self-reliance, and overall quality of life. Preventing and reversing sarcopenia starts with awareness, continues with nutrition, and is sustained through deliberate movement and recovery. Muscle is your body's biological armor, and in a world filled with stressors, toxins, and metabolic confusion, preserving it is one of the smartest health investments you can make. High-quality cheese, often misunderstood in mainstream health discourse, is one of the most efficient whole foods for delivering complete proteins, essential fats, and bioavailable nutrients critical for muscle synthesis, especially when it comes to combating sarcopenia and rebuilding lean body mass. While cheese has frequently been demonized due to its saturated fat content or lumped into a vague "dairy is bad" narrative, the truth is that certain types of cheese, particularly those that are aged, grass-fed, and minimally processed, offer a powerhouse of muscular support in a compact, easy-to-digest form. Unlike protein powders, processed meats, or synthetic meal replacements, cheese is a naturally fermented, nutrient-dense food that delivers a highly usable form of amino acids. These amino acids, especially leucine, isoleucine, and valine, the branched-chain amino acids, are essential triggers for muscle protein synthesis. When consumed in the context of an anti-inflammatory diet and paired with appropriate physical resistance training, the amino acid profile of high-quality cheese supports the regeneration of muscle fibers and satellite cell activation, which are key mechanisms in rebuilding aging muscle tissue. But protein alone doesn't drive hypertrophy. The presence of essential fats, especially saturated fats from a clean source like grass-fed dairy, is critical for hormone production, particularly testosterone and growth hormone, both of which play a central role in muscle maintenance. These hormones naturally decline with age, but dietary fats can act as raw material for the endocrine system to continue producing them in sufficient amounts. The endocrine system continues producing them in sufficient amounts. Additionally, fat aids in the absorption of fat-soluble vitamins A, D, E, and K, which are all present in high concentrations in traditional cheeses. Vitamin K2 in particular, which is abundant in aged cheeses like Gouda and Brie, helps regulate calcium deposition in the body, directing it away from arteries and into bones and muscles where it belongs. And this not only protects vascular health, but also supports the neuromuscular system by ensuring adequate mineral delivery to muscle tissues. Furthermore, the fermentation process that transforms milk into cheese also contributes to its bioavailability. Fermented cheeses contain enzymes and beneficial bacterial strains that assist in breaking down the casein and lactose, making it easier for the digestive system, especially in older individuals, to assimilate and utilize the nutrients. This is crucial because as we age, the stomach produces less hydrochloric acid and enzymes like pepsin, reducing our ability to digest proteins effectively. By contrast, high-quality cheese provides partially pre-digested proteins and fats in a form that's less taxing on the gastrointestinal tract. The calcium content in cheese is also notable, not just for bone density, which is often emphasized, but for muscle contraction, nerve transmission, and intracellular signaling. Without adequate calcium, particularly when paired with magnesium and phosphorus, which are also found in good cheese, the muscular system cannot fire properly, leading to cramps, weakness, and inefficient contractions. Another advantage of cheese is its portability and stability. For aging individuals trying to meet their protein and nutrient needs, convenience matters. Cheese doesn't require cooking, can be eaten as a standalone snack or part of a larger meal, and pairs easily with muscle-supportive foods like olives, nuts, or vegetables. In a society where fast food and processed snacks dominate the nutritional landscape, having a whole food that is ready to eat yet packed with the necessary building blocks for muscle repair is a game changer. It's also highly satiating. The protein-fat combo in cheese triggers hormonal signals like cholecystokinin and peptide YY, which reduce hunger and support appetite regulation, something essential when trying to maintain lean mass without over-consuming calories. What's more, high-quality cheese supports metabolic flexibility. Because it's low in carbohydrates but high in protein and fat, it's ideal for individuals on ketogenic, low-carb, or carnivore-style diets who want to preserve or build muscle while keeping insulin levels stable. This is crucial because high insulin levels, especially from frequent carbohydrate consumption, can lead to insulin resistance, inflammation, and impaired anabolic signaling, which compromises muscle growth. Cheese offers a metabolic advantage by providing dense nutrition without the blood sugar spike. For those who are insulin resistant, pre-diabetic, or dealing with chronic inflammation, including the right kinds of cheese in the diet can help modulate hormonal cascades and support mitochondrial efficiency, both vital for sustained muscle function. It's also worth noting that certain cheeses contain unique peptides and growth factors that support immunity and gut health, two systems intimately tied to muscle preservation. When the immune system is overactive or the gut is inflamed, anabolic pathways are suppressed and catabolism increases. By incorporating immune-supportive, gut-friendly cheeses, such as aged raw milk varieties, individuals create a physiological environment more conducive to tissue regeneration. In other words, cheese is more than just fuel. It's a biological support system that integrates into multiple aspects of musculoskeletal and metabolic health. When sourced and consumed correctly, high-quality cheese isn't an indulgence to fear. It's a functional food designed by nature to sustain strength, hormone balance, and cellular repair well into advanced age. Certain cheeses, particularly high-quality aged varieties, are exceptionally rich in leucine, a critical branched-chain amino acid, BCAA, that acts as the primary trigger for muscle protein synthesis. Leucine is not just another amino acid in the protein family. It functions as a metabolic switch. When consumed in sufficient amounts, leucine stimulates the mTOR, mechanistic target of rapamycin pathway, a central regulator of cellular growth and muscle development. This pathway governs the body's anabolic state, meaning it signals your body to build rather than break down tissue. For individuals facing muscle loss due to aging, stress, inflammation, or inactivity, conditions that typically accelerate the catabolic process, ensuring an adequate and consistent intake of leucine is non-negotiable for muscle maintenance and repair. Cheeses like Parmesan, Gruyere, and aged cheddar contain significantly higher levels of leucine compared to many other protein-rich foods. What sets these cheeses apart is not only their leucine content, but the bioavailability of that leucine. Unlike some plant-based sources of protein, which often lack complete amino acid profiles or contain anti-nutrients that interfere with digestion, cheese offers leucine in a highly absorbable form. The fermentation and aging process that cheeses undergo helps pre-digest certain proteins and fats, which reduces the strain on the gastrointestinal system and enhances the bioaccessibility of amino acids like leucine. This is particularly important for older adults whose ability to digest and assimilate nutrients can decline due to lower stomach acid production and enzyme efficiency. And in this context, cheese becomes an incredibly practical and effective delivery system for leucine and other BCAAs, helping to counteract age muscle loss or sarcopenia. What's especially compelling about leucine-rich cheeses is that they deliver this powerful amino acid in synergy with other crucial nutrients that facilitate muscle recovery and structural integrity. These include vitamin B12, which supports energy metabolism and red blood cell formation, calcium and magnesium, which assist in muscle contraction and relaxation, and saturated fat, which aids in hormonal synthesis, particularly testosterone and growth hormone, both of which decline as we age and are essential for building and preserving muscle mass. This nutrient matrix creates the perfect internal environment for anabolism, allowing the leucine to work more effectively and consistently without the metabolic imbalances that might arise from synthetic or isolated protein supplementation. Leucine also plays a role in blood sugar regulation and insulin signaling, two systems closely tied to muscle metabolism. When leucine levels are sufficient, insulin sensitivity can improve, allowing for better nutrient delivery into muscle cells. This is crucial because insulin is not just a blood sugar hormone, it also acts as a nutrient transporter. Muscle cells require insulin to help shuttle amino acids and glucose into the tissues where they're needed for repair and growth. By consuming cheeses rich in leucine, individuals may experience better glycemic control and more efficient muscle recovery post-exercise or post-fasting. This makes such cheeses an ideal food not only for aging populations, but also for athletes, fitness enthusiasts, or anyone looking to maintain lean body mass during calorie restriction or ketogenic dieting. Moreover, cheese provides a sustained release of amino acids due to its fat and casein content. Casein is a slow-digesting milk protein that continues to release amino acids into the bloodstream over an extended period. This is important because maintaining a steady supply of leucine and other BCAAs is key to sustaining an anabolic state throughout the day, particularly during times when meals are spaced apart or overnight during sleep. Unlike whey protein, which is rapidly digested and absorbed, cheese offers a more prolonged anabolic window, making it ideal for use as an evening snack or a strategic post-exercise recovery food. This sustained release reduces muscle breakdown and creates a favorable balance between muscle protein breakdown and synthesis. Additionally, the palatability and satiety factor of cheese cannot be ignored. Leucine has been shown in studies to suppress appetite and modulate hunger hormones like ghrelin, helping individuals control calorie intake while still supporting muscle maintenance. This is particularly useful for those trying to reduce body fat without sacrificing muscle mass, a delicate balancing act that becomes more difficult with age. The fat and protein combination in cheese, along with leucine's appetite-regulating properties, makes it a potent tool for metabolic health and body composition management. Furthermore, the versatility of cheese as a food source makes it easy to incorporate regularly into meals without relying on synthetic or processed protein alternatives. You can integrate leucine-rich cheeses into omelets, salads, grain-free wraps, or pair them with raw vegetables and healthy fats for a complete muscle-nourishing snack. This adaptability increases compliance with dietary protocols designed to combat sarcopenia or enhance lean muscle development. Whether you're following a ketogenic plan, intermittent fasting, or just seeking nutrient density from whole foods. In essence, cheeses that are rich in leucine serve as a bioactive metabolic ally for those seeking to preserve or rebuild muscle. They provide not just the necessary amino acids, but also the supporting cast of vitamins, minerals, fats, and fermentation byproducts that amplify leucine's anabolic power. When included regularly in a balanced, whole food-based diet, these cheeses do more than just nourish. They stimulate biological pathways designed to reverse muscle degeneration, optimize hormonal responses, and restore youthful metabolic function through a highly natural and sustainable approach. Fermented cheeses, unlike their ultra-processed counterparts, are living foods that deliver a powerful combination of nutrients, beneficial bacteria, and bioactive compounds that contribute significantly to gut health and, by extension, overall wellness. The human gut is often referred to as the second brain because of its vast influence on immune function, hormonal balance, mood, and especially nutrient assimilation. Fermented cheeses, such as aged raw milk varieties like Gouda, Brie, Camembert, and certain forms of blue cheese harbor naturally occurring probiotic strains, including Lactobacillus and Bifidobacterium. which play a pivotal role in maintaining the delicate ecosystem of the intestinal microbiome. These friendly bacteria help to balance gut flora, crowding out harmful pathogens, yeasts, and inflammatory microbes that are linked to chronic conditions such as leaky gut, autoimmune reactions, and systemic inflammation. The process of fermentation doesn't just preserve the cheese, it transforms it. Proteins are pre-digested, meaning they're broken down into peptides and amino acids that are more readily absorbed by the small intestine. Fats are also metabolized into short-chain fatty acids, which nourish the cells of the colon and act as anti-inflammatory agents. Additionally, vitamin K2, an essential fat-soluble nutrient that's difficult to obtain from the modern diet, is produced in significant quantities during fermentation, especially in aged cheeses like Emmental or Jarlsberg. K2 helps regulate calcium transport, directing it away from arteries and soft tissues and into the bones and teeth where it belongs. Without K2, calcium supplementation or even dairy intake can become counterproductive, leading to arterial calcification instead of skeletal strengthening. Thus, fermented cheeses serve as a natural vehicle for delivering both probiotics and critical co-nutrients in their most bioavailable form. Moreover, a healthy gut microbiome, which is reinforced through regular consumption of fermented foods, enhances the absorption of a wide spectrum of nutrients that are often poorly assimilated in individuals with compromised digestive function. Vitamins such as B12, magnesium, zinc, and even protein rely heavily on gut integrity for proper uptake into the bloodstream. This is particularly important for aging populations whose production of stomach acid and digestive enzymes typically declines, leading to malabsorption syndromes, fatigue, and even muscle wasting. By consuming fermented cheeses regularly, individuals can improve their microbial diversity and enzymatic activity, which in turn facilitates more efficient nutrient extraction from all other foods in the diet. This is not merely about the cheese itself, but the cascade effect it has on the body's entire nutritional economy. Inflammation, especially chronic low-grade inflammation, is a silent antagonist in nearly every degenerative disease, whether it's arthritis, insulin resistance, cognitive decline, or sarcopenia, age muscle loss. Fermented cheeses can help mitigate this threat by supporting the gut barrier. A compromised gut barrier, often referred to as leaky gut, allows undigested food particles, toxins, and bacterial fragments like lipopolysaccharides, LPS, to enter the bloodstream, triggering immune responses and widespread inflammation. Probiotics from fermented cheese help seal the gut lining, increase mucus production, and regulate immune tolerance in the gut-associated lymphoid tissue, GALT, which houses about 70% of your immune system. By maintaining this protective barrier, you can reduce systemic inflammation, support detoxification, and promote clearer skin, sharper cognition, and better muscular recovery. Additionally, the SCFAs, short-chain fatty acids, produced during fermentation are not just good for colon health. They communicate with the central nervous system through the vagus nerve, modulating brain chemistry, and even impacting neurotransmitter production, serotonin, dopamine, and GABA. Neurotransmitters responsible for mood, motivation, and relaxation are all influenced by the metabolites of healthy gut flora. Fermented cheese thus becomes more than a food. It becomes a functional, biochemical tool to recalibrate your entire system from digestion to disposition. Let's not forget that inflammation and malabsorption form a vicious cycle. Inflammation damages the gut, and damaged guts absorb fewer nutrients. This undernutrition then fuels further inflammation and cellular degradation. Breaking this cycle requires introducing foods that work with the body, not against it. Fermented cheeses are one of the few animal-based foods that offer this level of synergy. They bring together protein, fat, enzymes, probiotics, and fat-soluble vitamins into a compact, palatable form that is easy to incorporate into everyday meals. And unlike many probiotic supplements, which may not survive the harsh acidity of the stomach, the bacteria in fermented cheese are often more robust, protected by the dense fat and protein matrix of the cheese itself. This ensures more of them reach the intestines alive and able to colonize. While many still demonize cheese due to outdated beliefs around fat and cholesterol, emerging nutritional science and real-world results are painting a different picture. It's not about the cheese, it's about the type of cheese. Industrially processed cheese-like products are stripped of life, loaded with preservatives, and offer little to no health value. In contrast, raw, aged, and naturally fermented cheeses are alive, dynamic, and deeply nourishing to the gut and every system that depends on it. These are not just foods to enjoy, they are foods to heal with. When your gut thrives, everything else in your body does too, and fermented cheeses are a delicious and time-tested way to support that foundational health. Grass-fed and aged cheeses are nutritional powerhouses that deliver a unique and often overlooked compound, vitamin K2. Unlike the more commonly known K1 found in leafy greens, K2, especially in its MK4 and MK7 forms, is far more bioactive in the body, particularly in its ability to direct calcium to the right places. This fat-soluble vitamin plays a critical role in regulating calcium metabolism, ensuring it is deposited into the bones and teeth instead of soft tissues, where it can contribute to dangerous calcification. When you consume cheeses made from the milk of grass-fed animals and allow that cheese to age and ferment naturally, the vitamin K2 content is significantly amplified. This isn't just good for bones. It's foundational to hormonal health, cardiovascular integrity, and long-term cellular resilience. The relationship between K2 and bone density is straightforward but profound. Without sufficient K2, calcium from supplements or even dairy foods can get misdirected, often settling in arterial walls or joints rather than being utilized to fortify the skeletal system. K2 activates proteins like osteocalcin, which bind calcium and integrate it into bone tissue, increasing strength and reducing the risk of fractures or osteoporosis. For aging individuals or anyone with declining sex hormones, this is essential, as low testosterone and estrogen levels are directly tied to a reduction in bone-forming activity. By supporting the biochemical machinery that integrates calcium where it's actually needed, grass-fed aged cheeses help mitigate the silent epidemic of bone thinning and fragility that affects both men and women after age 40. What most people don't realize is how tightly testosterone levels and vitamin K2 are linked. Studies have shown that K2 not only enhances the expression of genes involved in testosterone synthesis within the testes, but also protects Leydig cells, the testosterone-producing factories in the male body, from oxidative stress. In other words, K2 not only fuels the production of this vital hormone, but helps preserve the cellular structures that make it possible in the first place. This has powerful implications for men suffering from age androgen decline, or what is now commonly referred to as low T. The decline in testosterone is not just about energy or libido. It has far-reaching effects on muscle retention, motivation, mental clarity, and even immune resilience. A regular intake of grass-fed and aged cheeses can support this endocrine axis without the need for synthetic hormone replacement, which often comes with side effects or dependency. The origin of the milk is crucial. Cows that graze on nutrient-dense pastures convert chlorophyll and sunlight into fat-soluble vitamins like A, D, and K2 through a natural biological process that is entirely different from the grain-fed, confined animals in industrial dairy operations. Grass-fed milk contains significantly more conjugated linoleic acid, KEA, omega-3 fatty acids, and naturally occurring K2, and this milk is used to create traditional cheeses, and especially aged varieties like Gouda, Edam, Brie, and Emmental. The fermentation process further increases the concentration and bioavailability of these compounds. Aging allows enzymes and beneficial bacteria to work synergistically, breaking down lactose and proteins, making the cheese more digestible while enhancing its nutrient density. For men and women focused on longevity, the synergy between K2 and other nutrients in cheese cannot be overstated. K2 works hand in hand with vitamin D3. While D3 enhances calcium absorption from the gut, K2 ensures that the calcium is deposited correctly. If D3 is taken in high amounts without sufficient K2, it can actually lead to soft tissue calcification, arterial stiffness, and even kidney stones. This is why nature packages these vitamins together in real foods. Aged grass-fed cheese offers this complete matrix: fat-soluble vitamins, clean protein, bioavailable calcium, and beneficial fats, all in forms the body can recognize, absorb, and utilize effectively. Unlike isolated supplements, real food offers nutrients in a complex, interdependent system that speaks the same biochemical language as your cells. Beyond bones and hormones, the cardiovascular system also benefits tremendously from K2. Matrix clay protein, MGP, another K2-activated enzyme, is responsible for inhibiting the calcification of arteries and veins. This is especially important in aging populations where arterial hardening contributes to hypertension, poor circulation, and increased risk of heart disease. K2 ensures arterial elasticity, supporting better blood flow and reducing the strain on the heart. And since testosterone is also influenced by cardiovascular health via oxygen delivery, nitric oxide production, and systemic inflammation, it becomes a full circle scenario. By protecting your arteries, you're also creating an internal environment where hormones can flourish and tissues can remain anabolic. Cheese also offers a palatable, easy to incorporate source of nourishment that doesn't feel like medicine. It's accessible, satisfying, and deeply nourishing, which encourages compliance. Unlike synthetic supplements, which often come with binders, fillers, and questionable sourcing, grass-fed aged cheese is a whole food, and when consumed mindfully, in its raw or minimally processed state, it delivers more than isolated nutrients. It delivers cellular information, instructing your body on how to rebuild, defend, and regenerate. This is the kind of intelligent nourishment that moves the needle, not just in labs, but in real human lives. Information: the aging body doesn't need more synthetic interventions. It needs the biochemical intelligence of traditional nutrient-dense foods like grass-fed, fermented cheese that carry ancient wisdom in modern form. When it comes to optimizing metabolic health, hormone balance, and digestive integrity, most people overlook the profound impact that the type of dairy they consume has on their internal systems, particularly cheese. Cheese is often demonized in mainstream nutrition for its saturated fat and calorie content, but the real distinction lies in how it's made, what it's made from, and how your body reacts to it. Choosing low lactose or aged cheeses is not just a preference for taste, it's a strategy rooted in biochemistry. These types of cheese have undergone natural enzymatic and microbial transformations that not only reduce or eliminate the lactose content, but also break down proteins and fats into more digestible, bioavailable forms. This is incredibly important for people trying to stabilize insulin levels, avoid inflammation, and protect their gut lining from irritation and dysbiosis. Lactose is the sugar found in milk, and like all sugars, it has the potential to spike blood glucose and insulin levels when consumed in large or unprocessed forms. For people dealing with insulin resistance, prediabetes, metabolic syndrome, or simply aiming to maintain a ketogenic or low-carb lifestyle, the presence of lactose can sabotage their efforts silently. Even small amounts of lactose can trigger insulin secretion, especially when combined with modern pasteurized dairy products that have been stripped of their enzymes and probiotic cultures. Aged cheeses like Parmesan, cheddar, Gouda, Swiss, and Gruyere undergo a fermentation process where bacteria feed on the lactose, breaking it down into lactic acid and virtually eliminating it from the final product. This makes aged cheese incredibly low in sugar and far less likely to provoke an insulin spike. Now, here's where it gets even more interesting. Insulin is not just a blood sugar regulator. It is an anabolic hormone that signals fat storage, inflammation, and when chronically elevated, leads to hormonal imbalances, including lowered testosterone, increased estrogen, and cortisol dysregulation. People who constantly elevate their insulin, often unknowingly through hidden sugars like lactose, create an internal metabolic storm that encourages fat gain, muscle loss, fatigue, and gut dysfunction. The beauty of low lactose and aged cheeses is that they deliver high-quality fats and proteins without the insulinogenic effect of other dairy forms like milk, yogurt, or even fresh cheese like ricotta or cottage cheese. But the benefits don't stop with blood sugar and insulin. Digestive health plays a massive role in how you absorb nutrients, regulate immune function, and manage systemic inflammation. Many individuals suffer from lactose intolerance, not as a random genetic flaw, but as an adaptive response to modern dairy processing. Pasteurization destroys the very enzymes that help digest lactose, while homogenization alters the structure of milk fat, making it harder for the body to break down. The result is bloating, cramping, acid reflux, and low-grade inflammation that can permeate the entire system. Aged cheeses, on the other hand, retain their natural enzymes and beneficial bacteria. These aid in digestion and help repopulate the gut with microbial species that improve not just GI health, but mood, immune response, and even skin clarity. Another advantage is the way aged cheese influences satiety and hunger signaling. Unlike processed cheeses or sugary dairy snacks, aged cheese is dense in nutrients. Vitamins A, D, K2, zinc, selenium, and bioavailable calcium, all in a form your body recognizes. This signals fullness more effectively, reducing the likelihood of overeating or sugar cravings. When your blood sugar is stable and your gut is happy, your brain is clearer, your mood is calmer, and your cravings disappear. That's the hidden power of the right cheese. It doesn't just nourish your body, it changes your behavior by balancing your biochemistry at the cellular level. In addition, many aged cheeses are naturally rich in short-chain fatty acids and conjugated linoleic acid, CLA, both of which have anti-inflammatory properties and support healthy fat metabolism. CLA in particular has been shown to promote muscle retention and fat loss, especially when combined with resistance training or a ketogenic diet. These compounds also support mitochondrial function, meaning your cells can produce energy more efficiently, an essential factor for people over 40 struggling with fatigue or muscle decline. You also have to consider the immune implications of poor digestion. When undigested lactose or casein proteins pass through a compromised gut lining, the immune system sees these fragments as foreign invaders. This can spark an immune reaction, leading to food sensitivities, skin breakouts, joint pain, and even autoimmune flare-ups. By switching to low lactose aged cheeses, you reduce the burden on your gut and immune system, preventing these silent fires from taking hold. Think of aged cheese not as a cheat food, but as a medicinal, functional food that delivers what your body needs without the baggage that comes with modern dairy. Lastly, sourcing matters. Cheese made from grass-fed milk contains higher levels of omega-3s, CLA, and fat-soluble vitamins compared to grain-fed counterparts. This makes the metabolic profile of the cheese even more favorable, and when these cheeses are aged naturally, without added sugars, gums, or preservatives, you're left with a clean, potent food that aligns with your body's needs instead of working against them. When you're trying to reverse muscle wasting, also known as sarcopenia, you have to think like a biochemist, not a calorie counter. Muscle loss doesn't just happen because you're aging or not lifting weights. It happens because of chronic nutrient deficiencies, hormone imbalances, poor protein assimilation, and metabolic dysfunction that accumulates over decades. The solution is not just protein shakes and gym memberships. It's targeted nutrition, and that's where the right types of cheese become a secret weapon, especially when combined with intermittent fasting and resistance training. This trio creates a powerful synergy that rebuilds muscle, enhances mitochondrial function, optimizes hormone levels like growth hormone and testosterone, and transforms the way your body stores and utilizes energy. Let's break this down. Cheese, when chosen correctly, is one of the most bioavailable sources of complete protein and healthy fat on the planet. But not all cheese is created equal. We're talking about grass-fed, aged, and ideally raw cheeses that are rich in key muscle-building compounds like leucine, methionine, CLA, conjugated linoleic acid, omega-3 fatty acids, and fat-soluble vitamins like A, D, and K2. These nutrients directly support muscle protein synthesis, mitochondrial regeneration, and hormonal regulation. Most people think building muscle is about eating more meat or upping calories, but that's outdated thinking. It's not about volume, it's about quality and timing. That's where intermittent fasting comes in. Intermittent fasting isn't just about skipping breakfast. It's a powerful metabolic tool that activates autophagy, the cleanup of damaged cells, boosts growth hormone production, improves insulin sensitivity, and primes the body to absorb nutrients more efficiently in a shortened eating window. When you break your fast with high-quality cheese, especially those rich in leucine and medium-chain fatty acids, you send a powerful signal to your muscle tissue: repair, grow, and regenerate. Leucine is the amino acid that acts like a light switch for muscle growth. It literally tells your body to turn on muscle protein synthesis. And when it's consumed after a fasting window, when insulin levels are low and growth hormone is peaking, the impact is exponentially amplified. Now, add strength training into the mix. Resistance exercise, particularly compound movements like squats, deadlifts, and push-ups, causes micro tears in muscle fibers. That damage is necessary. It's the trigger for rebuilding. But without the right nutrients immediately post-workout or during the anabolic window following fasting, your body simply won't rebuild that tissue efficiently. That's where nutrient-dense cheese comes in. Again, its combination of complete protein, saturated fat, and fat-soluble nutrients makes it an ideal post-fasting or post-training food. It doesn't spike insulin aggressively like high-carb snacks, and it supports testosterone production, especially when derived from grass-fed sources high in K2. Most people overlook how crucial fat is for muscle and metabolic health. Saturated fat has been demonized for decades, but your body needs it for hormone synthesis, cellular membrane integrity, and brain function. Cheese from properly raised cows contains the right kind of fat, anti-inflammatory, nutrient-dense, and hormonally supportive. Combine that with the anabolic environment created by fasting and resistance training, and you've got the perfect storm for reversing sarcopenia, even in people over 60. Let's not forget gut health. Fermented cheeses like aged cheddar, Gouda, Parmesan, and blue cheese contain natural probiotics and enzymes that support digestion and reduce inflammation. You could be eating the most expensive protein on the market, but if your gut isn't absorbing it properly, it's wasted. Fermented cheese enhances nutrient absorption, supports immune function, and contributes to a healthier gut microbiome, all of which indirectly support muscle retention and metabolic efficiency. When your gut is inflamed or leaky, your ability to build muscle is severely compromised. Fermented cheese helps seal the gut lining and reduce systemic inflammation, and allowing your body to fully utilize the amino acids and nutrients it receives from food. Timing is another piece of the puzzle. When you time your cheese consumption after a fast or following a strength training session, you capitalize on what's known as nutrient partitioning. That's your body's ability to shuttle nutrients to muscle instead of fat. This effect is magnified when insulin is low, cortisol is stable, and growth hormone is high, all of which are triggered through intermittent fasting. Consuming cheese at this time promotes muscle hypertrophy without the fat gain, something especially important for people with insulin resistance, metabolic syndrome, or hormonal imbalances. In this context, cheese isn't a guilty pleasure, it's a functional food. But again, it must be the right kind. Processed cheese, cheese slices made with fillers, or anything low-fat completely misses the mark. You want full-fat, aged, preferably raw cheeses from grass-fed sources. These not only provide the raw materials for muscle building, but also protect your joints, support brain function, and stabilize energy throughout the day. B, the combination of these cheeses with fasting and weight training doesn't just improve body composition, it reprograms your metabolism at the cellular level. You're not just maintaining muscle, you're rebuilding lost tissue, restoring hormone balance, and building a foundation of strength and vitality that will last for decades.